do that as well. And to talk about this, first I invite Jonathan McKay.
Hey, so I'm here to talk about push notifications in mobile web browsers. And this is going to be a joint presentation between myself, Jonathan McKay, Nate Schloss, who's an engineer on the browser partnerships team, and Owen Campbell-Moore, who's a product manager from Google. So this talk is actually going to go through some of the different parts of the tech stack. I'm going to talk about push in general and the reasons why we think that the mobile web is important, and push notifications are a key feature of the mobile web. Then I'm going to introduce Owen Campbell-Moore, who's going to talk about push notifications from the perspective of Google and why the Chrome team thinks that this is a really important feature that they should have. Third, Nate Schloss is going to come up and talk about how we've implemented push notifications via service workers in the Chrome browser on Android. And then to wrap it up, I'm going to talk about some of the implementations we've done for push notifications with browsers that don't have service workers. So the first thing is when we talk about the mobile web, a lot of people think that Facebook is a mobile-first company and that we've spent a lot of time working on our native apps, and that's all we care about. This is true. We really care about our native apps, and we've put a ton of effort into making sure that we have world-class apps for everyone around the world. We've done a lot of work, as you could see in our last presentation, about trying to make Facebook for Android one of the best apps, regardless of the network conditions you're in, what part of the world you're in, or how you're using Facebook. We've also put a lot of effort into Facebook Lite, which is made for people who might not have enough space or enough memory to run our main app. But the thing is, we still have hundreds of millions of people that are using the mobile web as their primary means to access Facebook. And so this means that if we want to have a mobile-first strategy, we can't be native only. We have to be where people want to be using Facebook, and this means browsers are going to be a key part of this strategy. The second thing is that the mobile web is still growing. A lot of people think that when there's been this transition from feature phones onto smartphones, the mobile web is becoming less and less important. But this isn't what we've seen. Over the last year, we've actually seen that the mobile web is becoming more important. And actually, in emerging markets like India, the mobile web can sometimes be the primary interface for a lot of people in terms of how they're going to access Facebook. Now, the problem is the mobile web isn't necessarily as good as our native apps in a lot of areas. There's a couple of key features that are missing when you talk about the mobile web. First, when you want to use Facebook via the mobile web, there's this additional layer of indirection that you have to go through. You have to open up the app, you have to type in the URI, and then you can start using Facebook. I remember vividly one time when I was doing some research in India, we spent about 15 minutes with a user on a smartphone with a really bad touchscreen, and we just could not type in m.facebook.com. That meant this simple layer of indirection meant she couldn't use the service. A second disadvantage is that there's no opportunities for bringing people back to the service. They have to proactively come to your site in order to find anything useful. Even if Facebook knows there's something that we think would be really useful for users, we can't tell them what it is. And the third thing is that the mobile web, in many cases, can be slower than a native app. And this is because we don't have as much control over the network. We're not able to cache local resources. And an interesting thing here is that proxy browsers like Opera Mini and UC Browser, what they've done is they've set up a proxy server between the web service and the native client that will actually try and speed up the web service for websites in a way that is not possible through traditional browsers. So when we talk about these disadvantages, we had to sort of prioritize which ones do we think are actually worth tackling to make our mobile web experience better. And what we found is that push notifications every time have been really important. First of all, we found that push notifications drive visitation on almost every platform that we launched them on. A few years ago, we launched push notifications on Nokia feature phones and found that this significantly increased the number of people that were using Facebook every day. When we launched push notifications on UC Mini, which is a very small web browser, and by small, I mean its APK size is very small, we found that people were using UC Mini and Facebook a lot more than they otherwise would. And the third thing is that for certain parts of our product that are very push notifications driven, like events, people actually will use this product within Facebook far more than they otherwise would without push notifications. So on our events product, push notifications have actually been a significant way that people will enter in to this product. So as you can see, push is something that as a web service, we knew could be really impactful for our bottom line. But this is something that Google and the Chrome team have also been looking at and also interested in solving. So to talk about their perspective on this problem, I'd like to hand it off to Owen Campbell-Moore to talk about how the Chrome team has looked at this space.
Good morning. My name's Owen, and I'm a product manager on Chrome's web platform team. So the web is an amazing platform. You can put up content that any user in the world can tap one single link and immediately access it. And that immediacy is something that I think we often don't talk enough about, especially when we compare it to the other main paradigm today, where you would drive users to, say, a store, you get them to accept a bunch of permissions, and then wait as a large kind of bundle downloads and installs. So the fact that users can access your content in a single tap gives you this amazing power of reach. So you can reach far more users than you could otherwise. And this reach is really great for companies like Facebook, large companies, and it's also great for small developers. Like when I work on my personal side project on the weekends, it means that I can drive a lot of users to it very easily and with very little friction. So a fantastic example of this is the newsreader app Flipboard. So Flipboard is a kind of mobile-first it's a mobile-first newsreader that for a number of years has been app-only. So earlier this year, they launched on the mobile web for the first time, and they saw a 75% growth in mobile active users in the 5 months after they launched. So we've seen time and time again how the low friction on the web can really drive usage. But as Jonathan said, there's a number of problems with the mobile web. So when I joined the Chrome team, we spent a long time thinking about these limitations and native platforms and mobile, and we came to an important realization, which I'd like to share with you today. The mobile web is not the desktop web on a smaller screen. So what does this mean? This means that we, as browser vendors, can't just take what's created success on desktop, shrink it down, and do that again on mobile. And the reason is that users interact with mobile devices fundamentally differently to how they interact with desktop devices. They stand and tap on icons on their home screen as they're waiting for a bus. And they have entire experiences built around rich interactive notifications. These key features have been fundamental to the success of mobile as a platform, but until recently, they've been restricted to native platforms only. So we took a step back and asked ourselves, how can we bring these great benefits of mobile to the web? So the first feature I want to talk about is addressing the problem that Jonathan identified of indirection, as he puts it. This is the problem that if there's a shiny app icon on the user's home screen, that's always going to win over the user opening the browser and kind of pecking in the domain of the website into the URL bar. So to address this, we've built a feature that we call promoting add to home screen. So the way this works is if a user visits your high-quality mobile optimized site multiple times, your site is now able to show a banner like you see here, which gives the user the ability to add that site to their home screen in just a single tap. This is amazing because it allows you to combine the reach of the web, bringing in all of those users, with the stickiness of an installed native app, but without the friction. The next feature I want to talk about is push notifications. Now, push notifications are why we're here talking today. They really are the holy grail of mobile. Not only do they provide great low latency kind of re-engagement, they also enable fundamentally new experiences. Messaging apps that we have today depend on that latency and just wouldn't be possible without a push mechanism. So for the last 18 months, the Chrome team has been working with other browser vendors and the standards community to design a standardized way for websites to send push notifications to users' devices even after the tab is closed. So in Chrome, a site like Facebook could show a permission request, like you see, asking for the user to give permission to receive notifications. Assuming the user accepts, the site can then send them a natively integrated push notification to their device days, weeks, or months later, even if Facebook is no longer open in the browser, and even if Chrome is not still running. So we think this is an incredibly powerful new feature. And the best thing is that this feature is live and production ready today. You can use this, it's shipped to stable in both Chrome and Opera, and it's landing in Firefox 42 this November. So we're extremely excited about this. And the other best thing about this is that you can write your code once, and because it's all based on standards, it'll work across all of those browsers and across mobile and desktop with no changes necessary. So I think this is probably the next question in a number of your minds. How does any of this work? The browser isn't even running, my tab isn't open, how am I receiving notifications and showing them on the device? And the answer here is service workers. So service workers are a fundamentally new primitive on the web that we, the Chrome team, have been working with the standards bodies to design over the last few years. So service workers are a new kind of web worker. But they exist outside of the context of a tab. So essentially, they're like writing a small piece of JavaScript that the browser is going to keep stored on the device somewhere, not running, but then can wake up and fire an event on if something interesting happens. For example, when a push message is received to the device, Chrome can just wake up Facebook's service worker, tell it that a new push message has arrived, and let it show the notification. Service workers are also fundamental to performance. With this new powerful capability, you can make huge strides in the area that we talked about earlier, particularly in loading performance. So the cool thing about service workers are, one of the things you can do is register to intercept network requests that go from your page. These essentially allows you to write a kind of local JavaScript proxy on the device. So for example, when the page makes a request to the network, it gets intercepted by the service worker. The service worker can then make its own network request to a server. This can be conditional on whether there's a network available or not. And it can also maybe read or write to some local storage of some kind, maybe an index database or the new caching API. And you can combine all of these pieces of data to generate a new response, maybe even run some templates, and then pass it back down to the browser. And so far as the page is concerned, it just spoke to the server, it spoke to the network, but you can do all of this even if there's no internet. You can really build these amazing experiences where all the data is cached, and you can build arbitrarily complex offline experiences using Service Worker. So Service Worker is an amazing new capability, and to tell you a little bit more about it in depth, and to talk about how Facebook's used it to implement push notifications on the mobile web, I'd like to introduce Nathan Schloss from Facebook. Thank you.
Hey, I'm Nate Schloss. I'm a software engineer at Facebook, and I'm going to talk a little bit more about the technical details of using service workers and using service workers for push notifications. So as Owen mentioned, service workers are event-based shared web workers. They exist outside of the scope of the web page and kind of persist even once the web page is closed. They get woken up by various events. There's generally like three main kinds of events. The events around their lifecycle, installing, updating, managing them. The foreground events, which are events that take place when the web page is open, so like network requests, things of that nature to run the web page. And then background events, so events that take place when the web pages may be closed, so maybe like syncing some data in the background or push notifications. So to install a service worker, the main web page thread has to do some work. It has to say, hey, register the service worker. And then after that, it keeps running normally, and all the work is done in a separate thread. So the performance impact on your main web page is like very minimal. Once the worker is registered, it gets installed and turned on, the code starts running, and an on-install event is fired to the service worker. It can use this event to maybe like pre-cache some data, like install dependencies, basically get ready to run and eventually be in charge of the web page. Next, maybe sometime later, a non-activate event is fired. This basically means the browser is ready to have the service worker be in charge of the page, and the service worker should get ready to take charge of this page. So the service worker can use this to like clean up old resources, maybe get rid of some old service worker code, anything it needs to do to be in charge of the page next. And next, the service worker is in control. This will either happen once the web page is refreshed, or the service worker can say, hey, I want to be in control now. And once it's in control, it gets all of the events that are supposed to go to the service worker. So all like the network events, all the push events, anything like to run this web page, the service worker will get now. So an example of some foreground events are events around fetching, so like network requests, things of that nature. And you can use like this plus caching and other like various APIs to run the page offline or really improve performance. And you also have this web worker. So you can post messages to it like a normal web worker and do some work there in a separate thread from the main page. So an example of some background events are maybe like syncing data in the background. So let's say you have a large video upload and you don't want the user to have to wait while this video uploads on the same page. You can do this, eventually you can do this in the service worker and have it like run in the background and not impact the main page and impact the user experience. This is currently available with a flag in Chrome and will be in stable soon. And then the other big background event is push notifications. So service workers will be woken up by push events, and then they can like fetch the notification data and display it. And because they're also woken up by push events and are running, they can do some work in the background too. So maybe like pre-fetch some data, basically like get ready for the notification to be clicked on and the website to be loaded. So using push with service workers is fairly simple. First, you have to register the service worker, and then you request a push subscription, which is a URL that you can send data to, and then it gets woken up by the service worker. Or the service worker gets woken up and can display a notification. So once you request a subscription, the user sees a permission screen. Then they click allow, the event finishes, you get the push subscription back, and you have to send it back to yourself, and then you can start sending requests to this URL to wake up the service worker. So the process of sending push is also fairly simple. You have your server, and it's going to send a message to the push provider, which basically says, hey, I have a notification. Now, the push provider has a persistent connection with the browser, and it'll say, hey, I have this event for this specific service worker. The browser will then wake up the service worker, and the service worker will go back to your site and fetch whatever notification content it needs to. You respond with your content, and then the service worker goes and says, hey browser, I have a notification, and the browser will then deal with displaying it in the OS somewhere. So the code for this will look something like this. You're going to subscribe to the push event, and then once you get this event, you want to wait until you've displayed a notification or done something with this data, because every time you get a push event, kind of the current paradigm is that you have to display a notification so the user knows that you're doing work in the background. If you don't display notification, sometimes an error message will show up, and it's not the greatest user experience. So it's really important that you wait until you've displayed a notification before finishing the event. Similarly, you have to listen to click events. So you subscribe in a very similar way to subscribing to push events. And also with this, you want to wait until the event is finished, or you want the event to wait until you've done your work before finishing. So once you have a click event, you're allowed to either open a new window or focus on a current tab. So you're going to fetch the URL somehow. Maybe you've stored it in the notification data. Maybe you stored it in IndexedDB. But however you store it, you fetch the URL, and then you're going to open it. Then you'll finish your event. There's a few things to keep in mind when doing this at scale. So one thing is when you're running multiple push events at the same time, if you get a new push event and you're currently processing an event, that can cause some weird buggy behavior where maybe you'll display an error message or you won't have content to show. And solving this is really simple. Basically, if you get a new push event and you're processing an event currently, you wait until the event you're processing is finished before processing the new event. And that gets rid of a lot of the issues you might run into. Additionally, displaying many notifications at the same time can be kind of an annoying user experience. And solving this with service workers is really simple because you can use tags to replace old notifications with new ones, and then you can use that to help limit the number of notifications you show. You probably also want to clear notifications when the page opens, as if you have 5 notifications from a site, then you open the site and all 5 notifications are still there. That can be a little bit annoying from the user experience. And you also want to consider using tabs. If you're in an active Messenger conversation and every time you get a notification you click on it and then it opens a new tab, you'll end up with 20 tabs open, and it's really hard to use the browser at that point because you can't find what tab you want, and it's not the greatest user experience. Reusing tabs is simple. You can get a list of currently open windows with the client's match all API. Then you basically have the service worker post a message to that client that says, hey, navigate to this new page. And then you can focus on the tab using client.focus. And if you don't have any tabs open, you can just open a new window at that point. So with service workers, we've seen some awesome wins. We've launched Service Worker Push on Chrome for Android, and it's doing very well. And we've also done some initial experiments with using service workers to improve just like performance on desktop. And we expect that if we were to really do a lot of work here, we could see about a 30% or more improvement in time to interact metrics by using service workers. So now I've talked a bit about service workers and push with service workers, but there are still browsers who don't have service workers, and push there is very important. To talk a little bit more about that, I'll bring back Jonathan.
Yeah, let's give Nate a hand. Awesome. So some of you might be thinking, this is great for Chrome, but what do you do in emerging markets where people might not be using Chrome? So what we've done is we've had to think a lot about having push notifications sort of everywhere on the mobile web where we can get it. And one of the primary cases is for browsers like Opera Mini and UC Browser. So what we do in this case is actually relatively similar to the way that we do push notifications with service workers. So you have the Facebook web service up here on the upper left. You have Google Cloud Messaging or some sort of push messaging service on the upper right. You have the operating system, and then you also have the browser. So what we do is rather than have the service worker as part of the browser register with the push service, the browser itself will actually take care of this. So what happens is that the browser will register a push token with a cloud service like any other native app. Then what we do is we have the browser pass this information on to Facebook, the web service. And from here, we can just send push to the cloud. The cloud sends it down to the operating system. Operating system, of course, wakes up the application. And hopefully, this will lead to people re-engaging with the site. So this is what we've done on UC Browser, UC Mini, and Opera Mini. What this means is that we have multiple browsers now where you can get push notifications and get some of the really key benefits of native applications, even if you're using the mobile web. So what I want everyone to take away from what we've all talked about here is that mobile first can't mean native only. And we've invested in these powerful new features with multiple browser companies. Google's invested in this. And this is something that you should all consider. It's a way to use the mobile web to get the best of both worlds, both the web and native applications. Every time we've brought a new feature to the mobile web, it's been a win. Thanks, everyone.